Here you go. Let me record the sixth sum where they've given the circuit to be like this, and you have a capacitor like this and a capacitor like this, which is nothing but Wheatstone's bridge. So you know this get converted. This is up and this is down, and this is up and this is down, with this running in between. Okay, and if this is P by Q is equal to R by S, this is compared with the Wheatstone's bridge. If P by Q is equal to R by S, they're the same ratio. Then no charge will flow through the middle wire. Therefore, these two will be in series, these two will be series, and the above and below will be in parallel. They've already given that it's 1 microfarad, each of 1 microfarad. So obviously, P by Q is equal to R by S is valid. So no charge will flow through the middle wire. So then 1 and 1 in series means this will be 1 by 2 microfarad. This 1 and 1 in series means it will be 1 by 2 microfarad. And those two are parallel shows that it's 1 microfarad is the equivalent capacitance. And this is being connected to a voltage of 6 volt. They're asking what is the charge. No, charge is Q is equal to C into V, and C equivalent is 1 into 10 to the power minus 6 into 6. So 6 into 10 to the power minus 6, or 6 microcoulomb is the charge. They might ask you, they asking energy stored, which is you can write as half CV square, which is half into C is 1 10 to the power minus 6 into V square is 36. So it's 18 microjoules will be the energy. So let's go to next question. I hope it's getting charged. Yes. Oh, it's getting recorded. So let's go to seventh question. The seventh question is this, where in your circuit is here. I'll just read out the circuit. So there's a 15 microfarad here, and there is a 5 microfarad here, and there is a 10 microfarad here, and there is a 10 microfarad here, and then connected, and you have a 20 microfarad here and a 10 volt battery here. So okay, as soon as you see this, this is in parallel, so it's 20. This is in parallel, so it's 20, and 20 and 20 are in series, so it's 10 microfarad, and that 10 microfarad is going to be in parallel with this 20. So 10 is in parallel, so then therefore it's 30 microfarad is the total equivalent capacitance. So once you get 30 to be the equivalent capacitance, what are they asking now? Find um, the charge acquired by 5 microfarad capacitor. This charge in specific they're asking. Okay, so let's redraw the circuit a little so that you're clear. You have this 15 microfarad and you have this 5 microfarad, both of them in parallel. You also have this 10 microfarad, and you have this 10 microfarad here. Okay, and this is a 15 microfarad and this is 5 microfarad. The question is about what is the charge that is flowing through this 5 microfarad. Okay, now this wire goes here and it gets connected to a 20 microfarad capacitor, and you calculate the equivalent, and this in turn is connected to 10 volt battery. What is the charge? Okay, you know that 30 microfarad is equivalent capacitance, and charge is equal to C equivalent into V. So C equivalent is 30 into 10 to the power minus 6 into V is 10. So it will become 300 into 10 to the power minus 6. So 300 microcoulomb is the charge that flows through here. Okay, when it goes here, there's a 20, and this whole lot is 10, right? So it is in the ratio 1 is to 2. 1 is to 2, and so when the capacitance is in the ratio 1 is to 2 and it's in parallel, and the charge will also be in the ratio 1 is to 2. So this will be in this wire, let me do it in red color. In this wire, it will be 1 is to 2, the 1 on the top and 2 at the bottom. So then that is the ratio at which it's getting split. So it's, let's look at the purple color. It's a 2 by 3 into 2 by 3 into 300, the total charge. So you know it's therefore 200 microcoulomb flows through here, and therefore what is remaining is 100 microcoulomb, which goes like that, and that has to be split between these two capacitors, which has got a 15 and a 5, and the voltage is the same, so which is like a 3 is to 1 ratio. So then in that case, you know what is going to be at this, it will be 1 by 4 of 100. So it will be 25, and therefore, it's 25 microcoulomb is what flows through this, and that is the question. So rest of it like this, you can continue and do, but the question stops with this. What is the charge acquired by 5 microcoulomb, 25 microcoulomb, 5 microfarad capacitor? So let's go to next question. So next question is the eighth question, where you have consider two conducting spheres of radius r1 and radius r2, where r1 is greater than r2. So they have given that r1 is greater than r2. If the two are of the same potential, so they're not connected by means of any wire, that word has not been given. So they instantly have same potential. Okay, and so which means it is 1 by 4 pi epsilon naught into uh, q1 by r1. It has the same potential as 1 by 4 pi epsilon naught into q2 by r2, but you know that r1 is greater and r2 is lesser. This gets cancelled, and if r1, they are the same potential. If r1 is greater, cross multiply q1 r2 is equal to q2 r1. Since r1 is greater, proportionately q2 will come down. If r2 is lesser, the q1 will go up. That justifies that q1 will be greater than q2. That I think is the question. Calculate, no, if the two of them share the same, have the same potential, the larger sphere has more charge than the smaller sphere. I have found that. Okay, state whether the surface charge density of a smaller sphere is more. Surface charge density, let's compare, which will be q1 by 4 pi r1 square. This will be q2 by 4 pi r2 square. You already know that um, r1 square is greater and r2 square is lesser. And you already know that q1 is greater than q2. q1 is greater than q2. So state whether the surface charge density is more or less than the larger sphere. It will be just the same, right? The surface charge density in both the cases will be the same, because you know that q1 is anyway greater than q2, and r1 square is greater than r2, and the proportion will also be the same. How do I identify that? You already know q1 is greater than q2. But by you have an R1 square and an R2 square comparison, and this is more and this is less. So obviously, this, so then obviously,